LeetCode 1557, minimum number of vertices to reach all nodes in JavaScript. Not a common JavaScript problem. Not something you'll do in JavaScript much, but a good thinking exercise. Given a directed acyclic graph with n vertices from 0 to n-1 and an array edges where edges I equals an array from I to I represents a directed edge from node from I to node to I. Find the smallest set of vertices from which all nodes in the graph are reachable. It is guaranteed a unique solution exists. Okay, so what they want to know is, we're talking about the vertices, that's the nodes. They want to find the smallest number of origin nodes, right? So 0 could be an origin. Well, could 2 be an origin? Maybe it points to 5, so it could be an origin for 5. But that's really the wrong way to think about this. The right way to think about it is to find nodes in this directed acyclic graph that don't have anything pointing to it, because everything points to something, right? Everything points to something else, and it points unidirectionally. 0 points to 1, it points to 2. 2 points to 5, but 2 already has something pointing to it, so it's not something that has nothing pointing to it. 4 points to 2, so 2 is pointed to by 2 different nodes. 5 is pointed to by 2. 3 is not pointed to by anything. So we can visually see here that 0 and 3 have nothing pointing to them. They're pointing to other things, but they have nothing pointing to them. And that's the solution. It says here output must be 0 and 3. Example 2. Applying that same logic, 0, 3, and 2 have nothing pointing to them. So those must all be origins. That is the smallest number of nodes or vertices that we can use to solve our problem. 0, 2, and 3. It can be in any order. The code is as simple as I've explained it. It's just 6 lines of code here. It's very simple. Has from is where we store all of the vertices that have something that is pointing to them. And then anything that's not in this has from doesn't have anything pointing to it. And therefore, we're going to include that in our answer. And since we have this nice n parameter, we can use that to loop from our ordered nodes. All right, our nodes have 0, 1, 2, 3, 4, and 5. So our nodes are numbered 0 to n-1. That makes it much easier. We know how many nodes are going to be there, and each node is going to have a number associated with it. So has from, we're going to create a loop for that to populate it first. And we're going to look at the 1 property of the edge, because the 1 property is the 2 property. The 2 property is from something else. We don't have to care what it's from. All we have to know is that it has something that's pointing to it. And we're not going to have any nodes that are off in the yonder. Every node is connected to something. So it might not be having something pointing to it, but it is at least pointing to something else in the graph. There are no disconnected nodes. It is a graph, not a collection of nodes that randomly exist. So for each edge, the 2 of that array, in this case it's going to be 1, we loop through edges 0, and then we get the 1 property off of that, which is 1 in this case. It happens to also have the value 1, is going to be true. 1 has something pointing to it, as does 2, 5, 4, and again we will iterate through and we'll add 2 again, which doesn't matter. We just replace the value true for 2 with true. Doesn't change anything. Now we're going to next loop through from 0 to the number of nodes, or vertices as they kind of vacillate between calling it. And then if we don't have it in our hasFrom object, we're going to push that onto our answer, and finally we will return our answer. That's all it is. It's essentially a 2n solution in JavaScript.